Welcome to Catalyst Grid. My name is Kingsley Amufua, your host. In this episode, we explore DCIM at 100 megawatts. As we move from single buildings to massive campuses, our approach to operational intelligence must evolve. Iron Gate's DCIM was populated at handover with a full asset register. Every rack, every PDU, and every cable was tracked. It provided a single pane of glass for the team, excellent for a 10 megawatt facility, but not enough for FULCRUM. At FULCRUM, DCIM is not just an asset register, it is an operational intelligence platform. We monitor 50,000 data points across this 25-hectare campus, using AI to drive capacity and maintenance. The hierarchy runs from the utility fiscal meter at the BSP, measuring total campus energy for billing and carbon reporting. Every megawatt that enters the campus and every kilowatt that leaves a server rack is measured with total precision. We track per UPS output and autonomy, along with 800 cooling plant metrics, including pump pressures and chiller COP. The scale is immense, 4,200 PDU measurements and 18,000 cabinet-level power readings. Environmental monitoring adds another 12,000 points, tracking aisle temperatures, humidity, and underfloor pressure. Even fire and security are integrated, with 8,000 points covering smoke detection and access events. Finally, we monitor nearly 6,000 points across our generators and fuel farm, tracking vibration and exhaust temperatures. This entire 50,000-point hierarchy is measured in real time, with updates every 15 seconds. The concept that truly distinguishes FULCRUM is the digital twin, a live virtual replica of the facility. Our digital twin is built on the LOD 500 as-built BIM model and populated with live DCIM sensor data. It is connected to a physics-based simulation engine, allowing us to model future states without physical risk. When the capacity team needs to add 200 more GPU racks to a row, they run the simulation in the twin first. The twin models the additional heat load, the CRAH response, and the impact on the cold aisle temperature profile. We can see the impact on PUE before a single piece of hardware is ever installed on the floor. This capability allows us to test and validate any change virtually, ensuring total operational safety. Our DCIM also includes an AI capacity management module trained on 18 months of operational data. The AI does three things that rule-based systems simply cannot match, starting with predictive cooling optimization. The AI analyzes the relationship between IT load and outdoor temperature to continuously optimize cooling set points. It learns seasonal patterns and the specific response characteristics of every individual piece of cooling plant. The second pillar is predictive maintenance, identifying failures before they even occur. The AI identifies patterns in vibration and power draw that precede equipment failures by 2 to 6 weeks. This includes early warnings for UPS module degradation, cooling pump bearing wear, and generator regulator drift. Early warning allows for scheduled maintenance intervention, completely avoiding the risks of emergency response. Third, capacity forecasting. The AI models the deployment rate at which new racks are loaded. It forecasts exactly when the next capacity threshold will be reached, giving the FM and commercial teams advance warning. This enables the program to be adjusted well before capacity constraints can become operational crises. Crucially, FULCRUM's DCIM is populated progressively through construction, not in the final week before handover. Every physical element is tagged in the BIM model at stage 4 with its DCIM ID, monitoring parameters and alarm thresholds. When equipment is installed, the site team scans its QR code to confirm, automatically linking the physical asset to its digital record. By the time DH1 reaches IT ready at month 36, the asset register is 100% populated and verified. The team receives a fully operational intelligence platform from day one, not a skeleton system they must build themselves. It is time for the series signal. DCIM population is a construction deliverable, not a handover task. Start building the register from the BIM model at stage 4 and complete it progressively through installation. Your operations team should receive a live calibrated system, not a data entry project to complete. Next time, we tackle project controls across a 42-month hyperscale program, multiple critical paths. We will look at phased earned value and Monte Carlo simulation at program scale, and we explore the claims management discipline that protects the SPV across a DBFO contract. Please subscribe, like, share, and comment. Your engagement helps us bring more technical insights to the Catalyst Grid community. Thank you for joining us. See you in the next episode.